Thank you, Leo. I'm going to do actually something that no one should do. Let's say live demo, but let's just start this. And you will see in a while what will happen. I have never done this. We are in a very far country. Sometimes I look like Google Maps. Sorry, I said Google. Or, I don't know, GPS. And I see that I'm very, very, very far. Even farther than, I'm from Colombia. I live in Italy, so it's already far. But from Colombia to here, it's actually even farther. So let's have some risk. Let's do something, let's say, live. So fast urban digital twin prototyping based on open data. So buzzword alert, urban digital twins. Who has heard the term digital twin during the week? Yes, exactly. If the ones that didn't raise their hand, you're lying. You're lying. I'm completely sure of that. So let's start a little bit with the outline of the presentation. First, let's get some context. So what is actually urban digital twins? Then let's go to let's say the application that we developed for prototyping. Then for the data requirements, the automated data download, and finally, a small use case to actually like wrap everything together. So context, the most important thing. First, what is actually an urban digital twin? I like very much this definition. I've seen many papers about urban digital twins. And I like this one because it, let's say, wrap everything up. So an urban digital twin or city digital twin is a spatial, temporal, visual representation of a real-world urban area, mirroring its state during its life cycle through IoT sensors, used to monitor and analyze urban systems, aid in decision-making, and it can be extended to simulate and predict states. So in summary, we have that the usage of geospatial and temporal data is important for urban digital twins. So it's a spatial thing and temporal thing. So you can go back, you can go forward, and you can visualize in the world. Then you have also the constant monitoring part. So it should be a double communication between the actual system and the real world. And finally, the analysis and simulation. So you can actually should be able to operate on the digital twin, on the digital, let's say, virtual visualization of the real world. So a little bit on the objectives of the research that we are currently doing with respect to urban digital twins. So basically, what we are trying to do is to identify how to actually build a system of urban digital twins, and then how to create an urban digital twin prototype. So how to actually like recreate or do something more generic for urban digital twins. So identify key data sets, because data is the soul of the urban digital twin, then develop the integrated software solution to actually like host and, let's say, create these urban digital twin prototypes, formulate an automated pipeline to actually create automated urban digital twins, and then implement everything for testing and validation with a use case. So this is a little bit the research that we are currently doing. And with respect to the system components and the data requirements for urban digital twins, we have that for the components, the three components that we found more important were the visualization, the processing, and the data management, something very similar to the previous presentation. And from the data requirement, we found that 3D data is actually fundamental. So most of the implementation for urban digital twins, we found that they use 3D data, and even sometimes they say that it's a digital twin, but it's more a 3D visualizator or visualizer. We also found urban street networks to be very important as a, let's say, urban data set. And other data sets like land cover, population, elevation models, and so on and so forth. We also found vegetation and so on. But these are the more important from the open data, let's say, infrastructure. And finally, we also found that IoT is very widely used for continuous monitoring. Okay. Now moving on to the actual platform, so the software that we use to create the urban digital twins, we proposed this platform called UrbanDT. Actually, the name was put 2 days ago. You can visit the GitHub, it's already public. So what is UrbanDT? It's an integrated software platform for hosting, for creating urban digital twin implementation. It supports 3D visualization, custom processing, data formats, OGC standards, OGC APIs, and it's based entirely on open source software. A little bit of the system architecture that we created for this platform. I will try to be very brief to go to the, let's say, the case study that is more dynamic. We have data management. We have the processing modules, and we have the user application, which is the actual visualization. So from the perspective of the core module, we have processing and data sharing. The processing is done through an OGC API server that we also develop in the Polytechnico that handles OGC API processes to create this analysis, and also GeoServer for the data sharing. So through OGC services, WMS, WFS, WCS, using GeoServer to actually share and connect the data with the visualization. Then we have the data management module because we need to store somehow the data that we're using. So we have two solutions, one related to PostgreSQL, PostGIS for vector data handling and for structured data handling, and one file-based, which I like to say that is for raster management and raw data management, but actually after hearing some of the talks this week, it could be also used for cloud. Let's say data management, for example, cloud optimized or cloud or read optimized GeoTIFFs, or SAR data that is also like raw-based data. We also have some metadata-based mapping for data discovery, and we handle many data formats such as GeoTIFF, GraphML also for the graphs of the street networks. And finally, from the point of view of visualization, we also have this user application. This is, let's say, the less advanced of the modules. It's based on a web visualizer called Piero, which is based on a 3D web engine called Giro 3D that handles, let's say, all the 3D visualization capabilities of the system, which is managed by, the visualization is managed by this, but it connects the data to the web application with GeoServer. We will see a little bit in a while. So this is more or less how the application looks like from the visualization point of view. So we spoke about the context, so what is a digital twin? We spoke about the software to actually create the digital twin, but let's talk about the soul of the digital twin, which is the data. So actually, this is more than the automated digital download, is how to assemble urban digital twin prototypes, because we are speaking about prototypes. But what actually do I mean with prototypes? By prototype, basically, is you have the system, which is what I already spoke, plus you have some base data. So the system without anything, it's just a system. It's something to hold. But the base data gives the urban digital twin its life. And by providing base data from global open sources, you can actually create this automated framework for creating urban digital twins. So from the base data requirements that we found for urban digital twins, we found these 5, let's say, data typologies. So we have, for example, the 3D city models, let's say, highlighting the importance for 3D data. We use actually, because you may know 3D city models from global open data, it's very difficult to find. So what we do is we used 2 building footprints with height information to create extrusions of the buildings to actually create some kind of 3D city model. We used OpenStreetMap, of course, for the street network. We created some algorithms and some processing to actually extract road, pedestrian, cycling, and public transport networks. We also use digital elevation model from NASA DEM, 30-meter resolution. We also download and use some land cover, 3 land cover data sets, which is the Copernicus, general land cover, Google Dynamic Board, like near real-time land cover, GHS build, specific urban land cover. And finally, we have also some data about population to also have this nice, say, analysis of population in the urban area. This comes from GHS POP, which is a multi-temporal 100-meter resolution population grid. This is a little bit the automated download pipeline for the data download. Some time for you to take the pictures. Still, the presentation is shared, so you can download it yesterday. Then, and you can take the pictures you want. So basically, just to summarize this, you have an area of interest, and you have raster data that is downloaded through Google Earth Engine. Don't mind, it's not open source, but we found that it was very easy to use actually because each of those data sets, they are accessed differently. So through Google Earth Engine, let's say we had this small caveat to, let's say, easily download everything. Also because it's a prototype, so you actually could, let's say, change this data for something more robust for actually creating a proper urban digital twin. We also have the OpenStreetMap downloader, which with filter and processing, we download all the different kind of street networks. And also for the 3D buildings that actually are 2D buildings extruded. So let's say we created 3D from 2D plus height information, and everything is fetched and let's say input into the urban digital twin system. So there are like two separate systems, but they work together to create the urban digital twin. So in the end, the urban digital twin, or how to assemble this, is that with a map extent and some configuration, plus the platform, UrbanDT, we create a minimal and reproducible, let's say, platform or prototype for an urban digital twin. And this is a little bit how it's let's say, what is the workflow for creating the urban digital twin prototypes. We have a map extent. We send this map extent to the configuration file, a Docker compose file, let's say, process, creates a multi-container Docker application that contains the database, the geo server, the processing server, the user application, and it's an amalgamation of services. It's an orchestration of services that in the end gives you all this. So the entire urban digital twin. And urban digital twins are actually a system of systems. So it's not a single solution, but it's an integrated solution of multiple systems working together to actually create this digital representation of the real world. So now let's go to the use case. And actually this is the part where I connect to the beginning, because what I was running was the actual, let's say, urban digital twin. So let's say if it worked, finger crossed. Yes, so actually I think I messed up because I'm doing myself some spoilers. So you can see this is, sorry for the visualization and the flickering, because actually I found out that from the global datasets for the buildings, there is no New Zealand. So bad for them. But I managed to also download some data from New Zealand. This is urban digital twin that I created just when we started. So this is where I also connect with the title. It's fast. So fast. We have also here some information about the road network, everything from the GeoServer, pedestrian networks. We have also some, yes, this is the urban one. We have some raster data. And all of this was downloaded from the beginning of the talk. So it's actually quite fast. So let's go back to the presentation so I can't finish. I still have some minutes, yes. So, anyone care to guess where this is? Okay, of course, I already spoiled myself, but yes, you are here. It's Auckland. Sorry about that. So, we created actually now, the urban digital twin of Auckland, or at least the urban digital twin prototype of Auckland. And some of the capabilities of the urban digital twin system are the data management and visualization, which are, let's say, in a good state with respect to other urban digital twin solutions, at least with the 3D and the 2D visualization, with the data, flexible data insert. So as I told you before, there is no global open data set that contains Auckland. So actually the data was input from Overture maps, downloaded and input a posteriori after the creation of the urban digital twin. We also have the GeoServer to share the data in standardized ways. From the processing and simulations, we are currently working on this. We support OGC API processes through one of the server that we use. It's called Rose API. We support asynchronous cloud-based processing, and also we provide two types of processes: street network analysis and raster-based. I will show you in a while. And from the part that they say there is still lacking a lot is from the constant monitoring part. It is theoretically possible to add constant monitoring data through the data management, because it allows you to connect to Postgres and so on and so forth, but we still don't have the capacity to actually show the constant monitoring data. This is something that we are currently working on. So a little bit of the results of the use case. We do some data exploration to actually see what data is in the prototype. We do raster-based analysis, I will show you in a while, and street network analysis to see how this is something that we are also doing in the research group, to actually understand or characterize urban mobility in the cities from urban digital twins. So from the data visualization, you already saw a little bit how it works with the 3D data. This is, let's say, based very prototype data because it's only the extrusions of the 2D buildings. But in fact, you can actually input more structure or 3D, more 3D, let's say, complete data sets, authoritative data. And we did that in one of the, this is also the work of my thesis. And for my thesis, we are doing a digital twin of Bologna, and they have authoritative data, and it looks much better than this because it's actually the authoritative 3D data for the city. So from the data exploration, we also have raster-based. This is the urban land cover for the city of Auckland. You can see a little bit the patches of the city specific, the roads here in yellow, where we can do also some kinds of analysis on the raster data. We also see here the digital elevation model that we can see this is tiled a little bit because of the GeoServer representation, but because we have also GeoServer, we can manage the styling from a, let's say, user perspective. So this is something also from the side of the extensibility of the platform itself. Finally, we also have some support for 2D data. We have also the building footprints that are not extruded. And we have also the street networks that we are also, let's say, showing them through WFS and WMS, but we actually have the data itself stored, so we can do analysis on them. And this is where all the analysis part comes into play. So we actually provide two types of analysis, at least by default in the platform, the analysis of street networks and analysis of raster-based data. And this is all dynamically done by the OGC API processes, let's say, application. We have in this case, this is an example because it is also dynamic in the way of creating the processes. We have, let's say, kind of a structured scripting system for creating the analysis. And here we have, for example, calculation of street network indices. Let me just take off the land cover. And here I already, let's say, run the analysis, and we can see here that we have the results for the analysis of a street network of the pedestrian. So we have actually like some specific characteristics of pedestrian network per street. So here we can see, for example, some indices such as the type of highway. So is it a footway? Is it a path? Is it stairs or something? We have where are the amenities closed. We have something called circuity, which is the straightness of the street. We have other information coming also from OpenStreetMap and so on and so forth. And we have also some information related to, this is the slope also, to see how difficult it would be to walk upstairs, uphill or downhill. So let's go back to the presentation. And just to wrap up, we did some small analysis for the street network, and actually we found that Auckland is very ideal, at least structurally, for pedestrian mobility in the city center. There is something we are not taking into account here, is slope, which actually affects a lot. I have the slope actually for cycling, but I think I will also add it to walking because it's a nightmare. I think New Zealanders have like very strong legs to walk in these slopes. So from the analysis of the street network for pedestrians, we found also some ideal conditions, at least from the, let's say, topological side of the street network, with low average street length, a very good connectivity with something called the link-node ratio, that is how many intersections with respect to streets segments are, and also from the connectivity, which actually the intersection density, which is actually high for one of the for this kind of cities. Also, we have very good in the functional part of the street network. We have very good average proximity to points of interest. So there is a lot of things to do in a, let's say, very close neighborhood. And also very good proximity to public transport, so it's very well connected with respect to public transport. And finally, just to wrap up with the conclusions, I think I'm just on time. The main achievements of this research was to identify the components and the base data for the urban digital twins. And then we've developed the Urban DT platform to actually prototype these findings on the system components and base data. Then we formulated a functional automated pipeline to actually generate automatically the urban digital twin prototypes from anywhere in the world, globally, using open data. And also the Docker-based automated pipeline for creating all this, just using a bounding box or an extent. And finally, the demonstration of everything is the implementation of the on-the-fly Auckland, New Zealand urban digital twin, and the performance of some specific analysis from the platform itself. What is for the future? Let's say we're still lacking a lot on the support for monitoring data, so how to actually integrate constant monitoring data, the temporal part of the urban digital twinning, and add more and more standardized formats. So for example, also have more support for 3D, for BIM, also connecting with what Federica was talking about, and also more support even for the 3D, because still this platform is a little bit lacking on the capabilities of the 3D. So maybe add some custom 3D visualization options and so on and so forth. Thank you very much for your attention. If you have any questions, I will be happy to answer.
Thank you, Juan Pablo. Do we have any questions? We have a lot.
Be gentle with me.
That's really great, Pablo. And one of my questions was, what did you do about simulations and analysis? And I think you responded that you're working on that. My question related to that is, the way you did it is you found the assets that you consider they are fundamental for digital twins, and completely agree with the sets of the assets. We found the same, we arrived at the same conclusion.
Nice.
And then you downloaded the data sets into static files, let's call them that way, so they are ready for analysis, raster data, 3D, etc. My question to you is, in a world where a lot of the data is becoming more APIfied in terms of, you find the web services rather than the raster behind it, how do you see that apply to the simulation? Is that even possible?
Yeah, we are in the beginning, let's say, we try to do it directly with the APIs or fetching data. But it's actually easier, to actually download the data and do everything local. And the idea behind this is not just to consume data, but also to be because in reality, digital twins are something hosted by organizations. So they actually need to have the data. So in the end, the idea is to have an integrated platform that can also, in the future, maybe can be used also even as a geoportal, for example, or as a place where you can find data, where you can do your analysis. So in fact, we actually provide the data, APIfied data. So yeah, the idea is to have the data inside. So the hosting of data inside of the platform, not consuming from external, because then you have to manage the connection, you have to manage the I don't know, maybe you have 100 data sets coming from outside, and then they change the API key, for example, or they change the API base URL. So you are, let's say, on your own. So the idea is to have the data in-house. And the idea behind this, at least this research, is to have the data in-house. So you can create your analysis from the data in-house. That's why we also download the data, and we provide this integrated platform to host and to share. So yeah, I know it's maybe not ideal from the let's say, interoperability point of view, but still, this could be also used for sharing your own data. So let's say we can go one step back and actually provide data ourselves. So hopefully I answered your question. Sure. After I get some sleep, please.
Hi there. You mentioned interoperability. It goes off similar concept. You mentioned you're pulling your data directly from GeoServer. So for any other visualizations, would that data have to come into your GeoServer system first? in all cases, like just for visualization, not for analysis?
In this case, yes. The idea is to have, I mean, again, to highlight, the data is inside the data management. So you get your data. There is actually, this is actually like very shallow of all the things that are inside. So this is my PhD thesis. You can imagine 3 years of development in this. And there is also a part of the platform that allows you to have, it's flexible in the way of adding data. So you have actually a connection from the Docker to your computer. So you can input your data. You can also input data to the database, and everything is managed inside. Also for the analysis, also again to connect with the previous question, you can have the scripting, say API that we created, can also handle the internal data. So you can have this list of data sets available through metadata. So yeah, in the end, everything is local. Let's say local as of the system, but it's not local to the internet. So you can host then, I mean, as of any platform, you can host them on the internet. They are accessible online, but everything is in the system itself. Okay? Did I answer your question?
Yep, I think so.
Thank you.
Any other questions?
One more in the back here.
Yep.
Thank you for the presentation. Can external real-time data, like for example, traffic or weather data from weather stations?
Yes, we are. Sorry, continue.
Yeah, I think that's be integrated into the urban digital twin.
Yes, as I was speaking at the end, we are working on it. We have let's say, it is possible to integrate data, at least from the data management point of view. We talked of that. That's why we also provided both let's say, the integrated database. So you can actually like connect directly to the database and input all your constant monitoring data. But from the visualization point of view, we are not yet in the visualization of the constant monitoring. Okay, so for example, you have an IoT, and this is external to the system. You have your own IoT system mounted. You provide an API to this IoT system. You can connect this IoT system to the service to actually like input all the data, and then through the visualization, hopefully next in some of the next iterations of the system, you can visualize this data, either through visualization of the seed network or through visualization from points or from any kind of thing you would like to do. But also as this is let's say open source, you can connect or you can do your own development on top of this. So if you want to also do some specific visualization, you can also, let's say, extend at least the visualization part. Okay. One more.
Have you also thought about implementing point cloud datasets into this, because they are also available? And
I mean, yes and no. I know that Piero, the application for the 3D visualization, supports 3D point clouds. So in theory, it is possible to implement them, but still we are not in that part. Again, everything is possible because it's file-based storage. So you can actually put a last file, for example. Then how do you share it? That's maybe the point where we are not yet, but you can have the information in the server, okay? And then we are going to work. I mean, there is a lot of things to do in the let's say, environment of urban digital twins, and every day new things are coming are coming new. We have a lot of format. We have CityGML, CityJSON. We have all the standards for the 3D tiles, for point clouds. So it's very difficult to actually like keep track of everything. The idea here again was to more from the theoretical point of view to structure the system. Now the system itself is to showcase how the system looks like or what are the capabilities of the system. But let's say the main point of the research is to propose this base data and base system components to create urban digital twins. Okay. Any more questions? Follow up?
Some proprietary packages claim that they give you a full digital twin implementation. Have you tried any of those?
Yes. Actually, yes, we have
tested?
seen some of them. even Terria. Yeah, we have seen some of them. We also like try to I also played a little bit with Mago 3D. We wanted to do something more like flexible from our side, because also for the research and everything. But yeah, also this is even I did some comparisons with my software and other software for urban digital twins, and they are somehow related. They have similar, let's say, capabilities, at least from the theoretical point of view. So yeah, let's say it's not something super new, but we also provide, let's say, more flexibility in terms of the data management, which is maybe the thing that lacks a little bit in other systems. Thank you. Any more questions?
Okay, thank you very much, Juan Pablo.
Thank you.